Hey guys, let's do an example of unit cell problem. So we got gold. Of course, gold is AU, and it crystallizes in a face-centered cubic unit cell, and it has a density, right? So face-centered cubic unit cell is important. It has a density of 19.3 grams per cubic centimeter. Right, we're going to calculate the radius of gold. All right, and so face-centered, that means, right, the edge on a face-centered cubic cell, right, is the radius times 2 times the square root of 2. All right. Now, one thing we need to know is how many atoms are in a face-centered cubic unit cell. All right. And so when we talk about a face-centered cell, I'm going to draw, well, that's not a square. Let's try that again. All right, let's make that kind of perfect. There we go. So face-centered, where are the atoms? I got one on the face, all right? And so kind of in the middle there. And then we're going to have one on each corner. So one there, one there, one there, and one there. All right. Now, technically speaking, these guys on the corner and the edge, the center, the face should touch, and they should all be the same size. All right. So I didn't do a great job, even with my tools, making that happen. All right. It's closer. All right. Okay, so that's the front. And so that's 1/2, and that's 1/8. Okay? So now, how many faces are there? Well, there's the front, the back. All right? There's the left, the right, and top and bottom. There should be 6 faces in a cube. So if we drew a cube, all right, there's 1, 2, front and back, 3, 4, all right, 5, 6 faces. So 6 faces times 1/2 an atom in each face would be 3 atoms. And then the corners, I have, right, when we talk about corners, we have 1, 2, 3, 4, 5, 6, 7, 8 corners on the cube. So 8 corners times 1/8 would be 1 atom. So that's a total of 4 atoms. So we have 4 atoms in our unit cell. Okay. In this unit cell, it's 4 atoms of gold. All right. And I need to know, right, with gold here, I need to know how big these 4 atoms are, so to speak. And I kind of can figure that out, because we know that there are 6.022 times 10 to the 23rd atoms of gold in 1 mole. And we know from the periodic table that 1 mole of gold happens to be 196.97 grams. And then we further know that for every 19.3 grams of gold, that is 1 centimeter cubed. And so if we do this math, right, and I'm going to use, I'm just going to use 3 sig figs as we have. I'm going to get 6.78 times 10 to the negative 23rd centimeters cubed. That would be the volume of the cell. Now, that's the volume. How does the edge compare to the volume? Well, we got the the length, the width, and the height, right? And they're all the same, right? W equals L equals H, right? Because it's a cube, right? So, which is the edge. So our edge would equal what to the volume? It'd be the cube root. 6.78 times 10 to the negative 23rd centimeters cubed. And if I go in the calculator and do that, I think we get 4.08 times 10 to the negative 8 centimeters. All right. And so if we do that for our edge, we know that our edge would equal our radius, whatever that radius is, times 2 times square root of 2. Well, if the edge is 4.08 times 10 to the negative 8 centimeters, that'll equal whatever r is, the radius, times, excuse me, 2 times square root of 2. And I wrote down a 3. Let's go with 2. And so we had to divide by the square root 2 to square root of 2 both sides. So it means my radius is going to be 1.44 times 10 to the negative 8 centimeter equals the radius. Now the centa, right? Remember centimeters, centa is 10 to the minus 2, right? Because we got to get this to angstroms, right? Angstrom, A with the, right? That's 10 to the minus 10th. All right. And so centa is negative 2. So this becomes 1.44 times 10 to negative 8, right? Times 10 to negative 2 meters, right? Which is 1.44 times 10 to negative 10 meters, which is the same thing as 1.44 angstroms. All right. So however you want to convert it, you can convert it, but that's that. So that is the radius of this gold atom. So hopefully that makes sense. All right. So what did we do to recap? We found out how many atoms are in a cell. And just so we know, simple cubic is 1, body-centered cubic is 2, and face-centered cubic is 4. All right? That's the number of atoms in a cell. All right? But you can always calculate it because of the shape and where they are. All right? And so then we had 4 atoms, and then we figured out the 4 atoms. We knew how many moles that was. Then we found out how many grams that was, and then we used the density, right? The density to get the volume. And once we get the volume, we can get the edge of a cube because we're going to only do in simple cubes in this course. All right? And so we take the cube root, and we got the edge. And then we found out the radius with the formula for face-centered. And then we just converted the number from centimeters to angstroms. Hopefully that works. And let me know if you have any questions. Take care.